Here's my solution to the dailyintegral.com easy integral from December 24th, 2025. So the original question is the integral from 0 to pi over 4 of cosine of 2x divided by cosine x minus sine x dx. Now the first thing you're going to notice here is that upper bound of pi over 4 makes this an improper integral because when I plug in that pi over 4, the denominator is actually 0. So if you want to do this one thoroughly, we have to look at the limit as b approaches pi over 4 from the negative side, the integral from 0 to b. So what's our integrand here? Now the nice thing is if you know your double angle formula, cosine of 2x is really cosine squared x minus sine squared x. Now that's being divided by cosine x minus sine x dx. But we can factor the numerator. So we get the limit as b approaches pi over 4 from the negative side, the integral from 0 to b. The top becomes cosine x plus sine x, cosine x minus sine x, divided by cosine x minus sine x dx. The cosine x minus sine x is cancel out, and then we just have to integrate cosine x plus sine x. Well, the antiderivative of cosine x is sine x, and the antiderivative of sine x is negative cosine x, evaluated from 0 to b. Sine of b and cosine of b, as b is getting close to pi over 4, those guys are both going to root 2 over 2, so they're going to cancel out. And we're left with negative sine 0 minus cosine 0. Well, sine 0 minus cosine 0 is negative 1, negative 1 is positive 1, so the answer is positive 1. So that's the answer. And to be fair, you didn't really need to recognize this as an improper integral to get the right answer because the cosine x minus sine x is going to cancel out anyway, so you wouldn't have even noticed it. But if you want to be thorough, if you want to be mathematically accurate, you really should have that limit as b approaches pi over 4 from the negative side in front. All right, that's it. It was a pretty nice integral. You got to use a double angle formula again, which are my favorite. So pretty nice.